Hello, today we are talking about correlational and multivariate research approaches. We call it multivariate only because there's multi-variables, right? So don't let that word already intimidate you. Correlational just means that things relate to each other, such as the images below as early sort of depictions of correlations without variables attached or anything. In this case, we just have two variables. Multivariate usually implies multiple independent variables and multiple dependent variables, something like that. In this case, we have what we call bivariate correlations, which is just two variables at once, x and y in this case, x being here 1 to 10, y being 1 to 100, and as someone's standing on x goes up, they tend to go up on y. On the left in graph A, it's not as predictable, if you will, as graph B. In graph B, for just about every slot you increase in x, you tend to go up in y. If that sounds familiar, it is probably familiar because it's geometry, right? It's y equals mx plus b or whatever in geometry. Here we do y equals, x, or some x times a constant and some intercept, we call it. So sometimes it's y equals bx plus c, with b being a beta weight or some sort of correlational coefficient for the strength of the correlation between x and y. Those intercepts just basically mean where they enter the y-axis. Anyway, so that's bivariate correlations, right? So those are two variables at a time, right? And there's tons of different things we could look at with bivariate correlations. Here they're looking at well-being and percentage of conversations rated as deep talk, right? So the more deep talk you have, maybe you have higher well-being. They can look at those different scores and see if there's a correlation, right? That basically means correspondence or something, right? So don't let that word either seem too complicated. Correlation just means that they correspond, right? Here's a couple more examples from your book. Like I said, there's a ton of different things you can look at with correlation. They can be continuous, as we say in the measurement world, where they're 1, 2, 3, 4, 5, 6, something like multitasking score you see there, or something that's a little bit more dichotomous or categorical. When you have more than two categories, though, the correlations fall apart. So you can't really do correlations with categories if those categories aren't meaningfully ranked. So there's a lot of different ways to talk about correlations. The most common is the quantitative correlation. This is when you have two continuous measures and you get a corresponding value of the relationship between those two quantitative measures of some sort, and that value represents the strength of that correlation. A person named Cohen, sort of put these baselines or categories out there for what is the strength of a correlation. So around 0.1 is weak, 0.3 is medium, 0.5 or larger is especially large for the social sciences. If you get a correlation of 0.5, it means those two things are very strongly related. 0.1, more of a scatter plot of dots, not as strong of a relation, if you remember those first two charts that we looked at. In some ways, you'll see these depicted as bar graphs, but that's not 100% accurate, because that's really summarizing the numerous different data points that you see there, like on the left, into mean levels on the right. You can do that for interpretation for like in journal articles, things like that, but if it's a correlation, it'll actually be between two continuous variables, more so than categories like that, summarized as mean scores to show, online versus offline, different levels of merit satisfaction in this case. Now, when we think about correlations, we can say that we interrogate them. I think that's a little bit of a strong word, but I'm using it based off your book. So when we interrogate claims of correlation or associations, we say, what we're doing is we're evaluating the evidence or evaluating the overall picture of what that correlation tells us. So we look at the construct validity, statistical validity, internal validity, and external validity, in that we want to know if that variable was measured in a way that aligns with our definition of that variable, right? That's sort of the construct, right? The statistical is whether the results from that measurement end up being statistically significant, right? So beyond p less than 0.05. So totally different than is the measure representing what we think it is. Internal validity relates to the cause and effect that we can claim or argue for based on our correlation and overall study, right? So internal validity is strongest in experimental designs, as we'll talk about later. And external validity, of course, is this correlation something that we can then assume relates, or that relationship holds for other groups, right? Or in the real world, right? Does it hold outside of this immediate study? So the first one, the construct, right? So how well was it measured? Does it have good reliability? So if we measure it multiple times, do people tend to have the same measure? Is it measuring what it's intended to, right? And then, face validity is the sort of lowest level or lowest fruit in that case. That there's some sort of, item in there that looks like depression. It's asking about depression. And then other sorts of arguments that you can make about the measurement scale itself that we talked about when we talk about validity, right? Does it relate to other concepts and things like that? So construct validity is important because we want to make sure that our measures are measuring what we think they are measuring, right? And if you find validated measures out there with citations like the Rosenberg self-esteem scale, we can be pretty confident that it's been gone through the test of peer review, that people do think that this definitionally holds in this case. Statistical is really what is the association there. So that correlation can really be interpreted exactly as you think. That is the effect or the relationship between those two variables. That p less than 0.05 is also important, but really the size of that correlation is important too. So the statistical significance is important, but really the size, the 0.1, 0.2, 0.3, that's also very important because it's really the degree that the variables overlap or correspond to each other, right? There's some statistical issues you can look at to see if there's outliers in your data. So if somebody scores really high on one variable and really low on the other, there could be a reason for that. And in some cases, I think the general rule is more than 3 standard deviations from the mean, but you can throw those out or do the analyses with and without those. That's very helpful. We also talk about range restriction and other issues like curvilinearity, and we'll have some examples of that in a second. But just to depict effect size, remember those graphs I showed you at the beginning? The scatter plot at the top is not as strong as an effect between x and y as that lower one, right? So the higher the value, the stronger the association. And when we get to something like regression, the more predictive power you might have with that sort of a relationship or x variable in predicting y. Statistical, like I said, is really all about the sort of rules that govern statistical significance testing, right? So the p less than 0.05, do you have sort of, let's say, errors associated with that? And then do you think it's, when we're talking about the logic of statistical inference, it could be a type 1, type 2 sort of situation that we'll get to. Type 1 errors being, finding a difference or a correlation that is not really in reality or doesn't externally generalize from this study. Type 2 errors being where you don't find a statistical significance, but you're pretty sure there is a relationship there. And that's common in studies with low n, like y'all will run. You don't get a lot of participants, so statistical significance is hard to obtain because sample size is in those equations. But you'll get a high correlation, an R, which is the letter we use to signify correlations, and R equals 0.2 or 0.3, 0.4. Those are high correlation values, correlation coefficients. So that in a normal study with a high sample size would be significant. Anyway, so this effect size, sample size, and significance are all intertwined in a way that looking at them individually is kind of important, especially when you get to your limitations of your study and rationale for what happened and whether it should be taken with some sort of confidence or not. When we're talking about outliers, I mentioned those, you'll see these depicted here, the red dots that are sort of far away from the rest of the dots, right? That just means that someone's score was extreme in a way that, maybe they were in a horrible mood that day, maybe they knew what the study was asking, or maybe they are really extreme, and we may not want to include those in the population. If you think about something like a depression scale or a self-esteem scale, if someone's at the extreme, it may mean that they're severely depressed. And they may be a special type of individual that may not be the normal individual you want to generalize to. Not that depression is abnormal, everybody suffers from depression, but when you think of the normal range of human emotion, severely depressed people might respond to stimuli differently. So you may want to say that in your discussion, right? Like, this may not apply to severely depressed individuals, but for individuals in the average spectrum, maybe they would have this relationship or whatever. Anyways, restriction range is when you don't get the extremes, right? Because outliers are only outliers because there's no one else like them, right? But if everybody was sort of skewing towards that range, they wouldn't be an outlier. Restriction range is when you have no skew, no variance in the extremes, and that lack of variability actually can create problems too, and can, we say, deflate or limit the size of the correlation that you can obtain from that study. So here's some different depictions of range restriction. And finally, the curvilinear aspect, which is interesting. They use a hospital example, but basically curvilinear just means that there's not a straight linear pattern to the data. Stress and anxiety work this way. In this case, it's saying that as you get older, your use of the healthcare system is first very high. You're born in a hospital, right? You go to a lot of doctors when you're young. And then when you get 20 to 40, you kind of forget to go to the hospital, or you only go if you absolutely need to. And then when you're older, you find reasons to go again. If you look at the Yerkes-Dodson curve, anxiety and performance, it's kind of a similar relationship. Finally, with correlations, what is important is the degree that these correlations are not just cross-sectionally spurious sort of results that do not really entail any causation. If two things happen together, we like to think that they have some relationship, and that, watching sad films or the degree of sadness of the film would make you more depressed. That relationship is somewhat causal when you think about it. So we want to argue for causality through correlations, but certain things are necessary to argue that. The average reader of a scientific study might assume there's causality when it's just correlational, or you just have that first level of causality, which we call covariance, that the two relate, A and B are similar, right? But the other ones, the temporal precedence and internal validity, are equally important. Temporal precedence just means time precedes, right? Preceding in time, so that A actually comes before B. Otherwise, we have what's called reverse causality. If B is actually causing A, that's fine if it's just correlational, but we want to know which is causing which. In experimental studies, we can actually manipulate A and see changes in B, and vice versa, and see that they stem from each other or not, right? Correlations cannot really do that. Maybe theoretically you could argue for it, but you can't say that one is actually preceding in time necessarily. And then the internal validity, the third variable problem, we'll go into a lot more, but that is the idea that there's another explanation, right? Usually you want to rule out other explanations, and with correlations you can't really do that unless you try to maybe measure those other variables, let's call that C, and see the impact of C on A and B. In some cases, the relationship between A and B is, we say, fully mediated or fully explained through C, something else, right? For example, if you think of A as grades in school and B is something like study time, that may look correlated, but maybe it's something like C, intelligence or income, SES, something like that, that's predicting both of them. So third variables are kind of problematic when they explain the relationship, right? And these graphs are attempting to show you that, in this case, between well-being and substantive conversations, again, that deep, sort of deep conversations that we were talking about. In some cases, the variables are sort of correlated, and then in another case, there could be an extra variable that's explaining those two correlations, right? Anyways, go back and review those. Moderating variables are a type of this where it's an explained or maybe predicted even variable that either exacerbates or limits the effect of the IV on DV. So we think of moderators as sort of a statistical interaction. In this case, they're looking at an interaction between team success and game attendance, that correlation, based on whether the areas were very traversable, or if people could get around to the games to actually attend, right? So the type of city you're in determined the relationship between the team succeeding in this case and people attending the game, right? So when people were highly mobile, the correlation was high. When they're not mobile, there's an opposite correlation, or a negative correlation actually, between attendance and success. So the city there would be the moderator, right? These are a type of multivariate design, right? So not just two variables, there's extra variables to sort of help explain these different elements of cause and effect that we want to explain. In this case, mostly internal validity, right? So what we're doing here is ruling out sometimes third variables or including them. A moderator is really a hypothesized type of third variable, but in other cases we want to just make sure that something like income or socioeconomic status or something like that isn't explaining that relationship, right? Acting as a sort of nuisance third variable. So we can use regression to sort of do this, certain sorts of regression equations where we add predictors into the sort of regression equation, and those predictors help explain the criterion, or they don't, right? Predictors being IVs, criterions being DVs, but still does not establish causation because it's just a form of correlation, right? We're just adding these variables in to see their overall impact on the outcome. So again, if we're looking at, let's say, school grades by study time, putting in that third variable of intelligence would show you the impact that has above and beyond. And then you can actually statistically parse that out. And you'll see when your book talks about that, that you can actually look at the effect and then take that effect out and see the true effect or the pure effect of just studying, let's say, on grades or that IV on DV, taking out the effect of that intervening variable or this third variable. So here they're looking at pregnancy risks and TV sexual content. I think they have a third variable in there, which is, in this case, what is the third variable here? Pregnancy risks, exposure to sexual content, and maybe it was age. Well, anyways, you can see the numbers are sorting themselves out, where on the left graph, you see all the 16, 18, and 20-year-olds are actually responding in different ways. On the left, you see there's not really a systematic pattern to the ages within those within that bubble. So it's not really acting as a third variable. On the right, you see that there's all the 18 in the middle and the 20. So you see that there's a pattern there. And sometimes really just looking at the data helps you identify that. But we can also do that statistically, of course. Anyways, moving on. Remember, this is between criterion and predictance. So criterion, remember, is the dependent variable. Predictor is the independent variable here. So you're trying to control for some sort of relationship between those two predictor-criterion relationships. In this case, it's multiple regression results from a study predicting pregnancy from sexual content on TV and age. So they're looking at that sort of age as an extra predictor variable, which in this case had a strong effect, 0.33. Beta is this like correlation is fairly strong, right? And you can add a ton of these predictors, a ton of what we might consider third variables or problematic variables to this mix to see if each of them has some sort of impact. And you see a lot of these actually do in this case. I'd revisit this one as well. So we talked about moderators. They're a type of third variable. Mediators are also a type of third variable that I referenced earlier. And what this does, again, is it helps explain that internal validity of the study, or the cause and effect relationship. In this case, we're looking at the deep talk again on well-being, and the mediator here would be the quality of social ties. So unlike a moderator where it's exacerbating, here with a mediator we're saying that deep talk actually causes social ties, or better social ties, which then increase well-being. So path A and B are actually important. C might disappear or become non-significant when we control for that other relationship. So it's all about why or for whom with the different types of moderators versus mediators, right? I like to say mediators are a floodgate, but you can also say sort of why or how is this change happening, right? Moderators are more group distinctions, right? So this effect happens for men but doesn't happen for women. That's more of a moderator, causing a change in the effect, if you will. But remember, regression is still like correlation. It's just using correlational sorts of statistics. So it's not necessarily ruling out those third variables. You're just measuring them and sort of modeling how they act in this process. So there's other ways of establishing evidence, such as temporal precedence, right? So remember, it's covariance, the elimination of these third variables, and the temporal precedence that implies that A actually happened before B, right? So longitudinal studies can address this, but longitudinal studies don't necessarily have the power to control all third variables, all those external variables, because we're doing it in the field many times, right? If we're not doing it in the field, then maybe we're tracking people over time, but we can't control those people over time. So third variables then introduce themselves again to this sort of experiment. But true experiments are where we're manipulating stuff, right? If you want to see something happen over time, usually you can't manipulate that within a lab setting. You have to give it time to actually happen, right? So longitudinal studies capture that growth over time. So, like I said, they can provide some evidence for cause and effect, especially that temporal precedence. And of course, you might see covariance, as certain things happen in your life. Let's say those conversations in your life, you maybe have higher well-being, right? So you can watch those develop over time. You can see them correlate, but you can't necessarily rule out that there's other things like family structure, income, other things that create those deep conversations maybe. So why not do an experiment again? Well, again, it's not always possible, right? If you want to assign people to smoking conditions, we can't assign that, so that's an ethical issue. And we can't assign people to sort of religious preferences, political preferences, things like that. Those sort of naturally occur. But not being able to randomly assign those then limits us or handcuffs in our ability to say that the internal validity is as strong as it could be, right? So correlational, multivariate sorts of studies are all non-experimental, right? They definitely argue for covariability, that first element of cause and effect, and sometimes a little bit of that third variable problem when you look at moderators or mediators or third variables, but their hardest element is the temporal precedence, right? It's hard for non-experimental correlational regressional techniques to argue for temporal precedence. But they are great ways to collect data, and as I said earlier, you can control for a lot of those third variable problems when doing correlational studies. So you can get a pretty clear image of what is contributing to your outcome of interest. Let's say in terms of this picture, smoking or smoking cessation, you can capture a lot of different independent variables or predictors and see their independent correlational, regression weights on the outcome, the smoking outcome. Anyways, I hope this makes sense. Go back and listen. There's a lot of nuggets in there of stuff, so hopefully that